And we'll definitely have time for Q&A because that's the part of this talk that I enjoy the most. So let's get there quickly. All right, let's go. So again, we were introduced very graciously. Although I must say that introduction doesn't tell the full story. That's the boring part of me. The more interesting part of me is I scuba dive, I do wildlife photography, I have 2 dogs. So if any of you want to talk about that, we can chat later, but that's the more interesting part of me. Ricardo, anything you want to?
Nothing to cover about an introduction.
Yeah. So I was here last year, exactly a year ago, and on the same stage. And a year ago, I spoke about how at Shopify we were using LLMs, fine-tuning LLMs, and how we were using multimodal LLMs to do large-scale inferences to extract structured metadata around products. I'm happy to say we've made a lot of progress there. We've scaled up systems. We do over hundreds of millions of inferences daily using some of these systems. So it was a great talk. I enjoy it. If those of you are interested, I think it's online from last year's talk. I encourage you to see that. What I want to do today is tell you the other half of the story, right? Because last year I spoke about, hey, we have this structured taxonomy system that at Shopify, and then we use LLMs to take products and put it into this taxonomy space. And today I want to talk about the other half, which is, hey, that structured taxonomy we spoke about, how do we evolve that system, right? Because it's not static, right? Like the world changes around us. 100 years ago, we were all being driven around in horse carriages, and today there's a new category called cars, and then there's like rocket ships and all of these things. So commerce changes, right? Like the world around us changes. So we couldn't sit with the static, here's all the categories and attributes in the world, and that's all, we're happy with it. And so today we're going to talk about that part of it, which is like, how do we use AI not to predict products into the taxonomy? I already did that last year. What we're going to talk about is how do we use agents to look at the taxonomy itself and how do we evolve that system. And so without further ado, Ricardo is going to take you away and then I'll come back.
Yeah, so the agenda is, as we have been saying, so we are going to be presenting the challenge and how we scale product taxonomy across every industry. Then we're going to go through the different strategies that we have been doing, creating this pipeline with LLM agents, LLM-as-Judges, and humans in the loop. And we will have some closing thoughts and some examples as well that we will be presented throughout the presentation. So just taking a step back, as Kay was saying, I just want to give a quick introduction on what is Shopify's taxonomy. Some of you may be familiar with it. Some of you may be familiar with other e-commerce taxonomies. Shopify's taxonomy is so to speak, the structure that is powering all the data, all the raw data that our merchants have, millions of merchants across the globe in their products. We are providing a structure so that we can understand what their products are and that merchants can leverage this information as well for a lot of different use cases. I will give you a few examples about that. What is Shopify's taxonomy today? It consists of more than 10,000 categories across 25 different verticals. We have merchants that are selling a vast array of different products, and we want to have a category for each one of them. So from fashion, in apparel and accessories, to hardware, to vehicles and parts, think of it, we should have a vertical for it in our taxonomy. On top of those categories, a category for those who are less familiar with the taxonomy is the main concept, the underlying structure of what a product is. So is this a shoe? Is this a t-shirt? That would be a category in our taxonomy. And then on top of that, you have a layer of attributes. What is an attribute? You can think of an attribute as the easiest way to explain it. It's like a filterable capability. So I have a product here. This is a t-shirt. I know that a t-shirt is conceptually different from a shoe. That's true. But even inside a t-shirt, if I am a buyer, I'm looking for a particular type of t-shirt. I'm looking for a t-shirt that is blue. I'm looking for a t-shirt that has my size M. And those are the attributes. Now, today in the taxonomy, in Shopify's taxonomy, we have over 2,000 attributes for these products and these categories. And on top of that, behind the scenes, we have these powerful models that Kay was mentioning about that are making predictions, inferences on those categories. So for any merchant that goes in the admin, in Shopify's infrastructure and create their products, we'll be providing for them the closest category in our taxonomy, and the attributes, as you can see here, the attribute predictions. So this is one way of surfacing the predictions that our models are doing behind the scenes. And this is powering 30 million daily predictions on the taxonomy, our models per day. And now it comes to the problem that us taxonomists at Shopify find every day. So we want for this taxonomy to be as comprehensive as possible. We want for every merchant to have categories, to have attributes that apply to their products, that help them structure this data in a way that makes sense for them, for their industry, for their specialty. And that's why for us taxonomists, we continue to evolve the taxonomy. We know that there are necessarily gaps in every single taxonomy. You cannot cover everything. And what we have been doing so far is a more traditional approach. So we receive, because our taxonomy, if in case you didn't know, it's open source. So we have a repository that is accessible to everyone. And you can go and suggest to make changes. Maybe there is a category that is missing and you can make that suggestion. And in our team, what we're going to do is go through that suggestion and analyze it. And if at the end we think, okay, this is a gap that we have in our taxonomy, we will add another category for you. But this is up to a few months ago, this was relatively manual. So taxonomists thinking about this. If you think about the more typical path of a taxonomy is building expertise around one area. So maybe there is a taxonomist that has a particular interest in vehicles or in fashion, or they have worked for a fashion company before, and that's the main area that they are a specialist in. Then obviously you can become a specialist in other areas, etc. But it's very difficult for any single taxonomist to have domain expertise on all the different products, all the different areas that we are expected to cover at Shopify with our taxonomy. And that is why we thought about this system with LLM agents, LLM judges, to help us empower and scale up all this work that humans weren't able to catch up with. And Kay, if you want to continue on that part.
So, don't worry too much about the graph there. We will talk about each of these pieces in detail in just a few seconds. But I want you to conceptualize a horizontal line right about here, wherever you're seeing. And the reason for that is when we first started out, like I was naive, right? I was like, hey, this seems like a stupid problem that I can just throw at an LLM. It's great, it'll just solve it. Quickly realized, no, it's not that easy, right? Because there were so many exceptions, there were these tiny things, and you would kind of go, if only I add this to the prompt, it'll work, right? And so we went through this exercise of just prompt tuning a little bit, tweaking it a little bit, building evals, and you were doing all of these things. And then at one point, I kind of stepped back and I said, wait, this isn't working, right? Like you can't just keep throwing things at a prompt and hoping things work. Let's break it down, right? And so as in any other problem-solving space, I believe that the first thing you do when you're tackling a relatively large, complex problem is you break it down into its component parts, and then you solve each of those component parts by itself, and then hopefully the sum total of everything that you solved is greater than the sum of each of those individual parts, which is kind of what we did here, right? So we decided very early on that it was going to be not possible to build one single thing that does everything. And so we said, okay, let's talk about what the component parts are. Let's break it down into these smaller agents. Each agent is doing one very specific thing. And then we can measure that specific thing properly, and then we can make tweaks at that level. And so that's the first thing we did, and we will go down into what each of those things are. But again, just to kind of reiterate, conceptualize a line right about here. Right? And I'll come back to that in just a second. So what we did is at the very top, above that horizontal line I just asked you to conceptualize, we have 4 separate agents, right? And so you can read the names of these things here. It doesn't really matter what the names are. But the first 2 are essentially the goal of those agents is to kind of go, hey, take a look at the taxonomy. And once you look at the taxonomy, give me suggestions of changes that should happen here. And changes can be many things, right? Changes can be, hey, add a new category, like this category should belong. Or it can be, hey, delete a category. Like maybe that category is no longer relevant. It can be add a new attribute or take an existing attribute, but connected to a category that didn't have that connection before, and so on and so forth. So there's many different changes that you can possibly make. And the first two agents that we have here are essentially going to be suggesting those changes. So now you might ask me, why do you need two agents to do the same thing? Why not have a single thing that does the same thing, right? And the answer to that is each of them, yes, the goal of what they're doing is the same thing, but how they get there is different. The context in which they're operating in is different, right? So the first one, which we very boringly call the structure analysis agent, what it does is it basically takes a look at the taxonomy, the entire big structure. It's able to traverse the taxonomy, it navigates, it has all these tool calling ability, it goes and it searches, and it thinks logically, right? It basically says, hey, with my understanding of the world, I have traversed this taxonomy, and based on what I have seen, these are the changes that it needs to make, right? So the context in which it's operating is essentially the generic knowledge that the base model, let's say GPT or Claude or whatever is operating it, and it's saying, hey, based on my understanding of the world, these are the changes that we want to make. That is the most naive agent we have. So then the very next agent that we built is essentially still doing the same thing, but now it's saying, hey, I'm going to do the same task, but in the presence of existing products, right? So basically what that means is I can say, hey, take a look at the guitar section, right? I'll say, take a look at the guitar part of the taxonomy. Here are products that we think are guitars. We've classified as guitars. Take a look at all of these products and see if you would further subdivide them, right? And it is interesting because what you start noticing is they both give you changes, but the changes look very different from one another. And I'll give you a very simple example. Shoes. When I ran for the first time this thing for shoes, and I said, hey, think of new categories and new attributes, the structure analysis agent was telling me things like, oh, heel type and closure, and there's a bunch of things which I don't understand shoes that well, but it was telling me a bunch of things like that. And the product analysis agent interestingly said, player signature line. And I was like, wait, what does that mean? And it turns out Jordan and LeBron and all of these, like there are specific products that we were seeing where like specific athletes were had their own signature brands and models and stuff. And the product analysis agent was coming up with those kind of changes, whereas the structure analysis agent was just logically looking at a shoe and going, these are the kind of things that define a shoe. And so both of them are valuable for us in the taxonomy. And so we build this dual thing and it runs parallelly. In the future, I envision more parallel agents all running together. And so great, that was working, right? The next problem for us is then, okay, if you have that, what happens with the merge? Like, how do you get all these different suggestions? How do you put them all together? How do you get a comprehensive view of the world? Then we said, oh, why don't you just throw another agent at this, right? Like, and it's important here because we could have done it deterministically. I can say, hey, if it says X here and it also says X here, then it's the same thing, cool. I could do it deterministically, but then semantics matter sometimes, right? Like the way agent number 1 would describe something might be slightly different from the way agent number 2 does, and how you would merge them kind of differs. And so we built a separate agent that says, hey, take a look at what all the other agents are saying and then kind of intelligently merge them together. And then finally we also realized that how we view the world cannot be one-dimensional. And what I mean by that, I'll give you an example. There are certain merchants who are selling, let's say, a golf shoe, right? They're selling golf shoes, and how they would categorize a golf shoe would just change depending on the merchant, right? Like merchant number A might say, hey, I want golf shoes to be under apparel and accessories. Under that, I need probably it's in accessories and then shoes, and then under that, I need golf shoes. Great, right? Merchant number 2 comes in and says, actually, that's not what I want. I want golf shoes to show up under sporting goods. It's sporting goods, golf, blah, 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 golf shoes. And that's a problem because in the taxonomy, you're kind of like, well, those two things are the same thing, but I don't want to put them in the two places. But it turns out merchants want us to put it in both those places. And what the last agent does is says, okay, you put them in those two places, but I'm going to draw this imaginary line that says this node in the taxonomy here connects to this other node in the taxonomy, and those are essentially equivalent to one another. And so these are the 4 agents we have, and all of these agents sit above that horizontal line that I spoke about. Now, what comes below that line, right? Like, cool, okay, you did all of this. How good is this? Like, like these agents are great. Can you just ship? Turns out you couldn't, because a lot of what we were initially getting was crap, complete crap, right? And it turns out that we were at a place where I had to go to Ricardo and say, hey, Ricardo, just can you manually verify all of this? And he tried his hardest, and then he said, no, I'm tired. I can't possibly be manually curating all of these changes that your system is giving. And so that's when we realized, hey, we need an agent judge here as well. So which is why in the bottom of that, so everything above that line is suggesting new changes. Everything below that line is deleting changes, right? So you have this antagonistic system where one thing is saying, hey, add this, add this, add this, and the other thing is going, nope, I'm not going to add it. I'm going to be the gatekeeper here. And so we built a LLM-Judge. Even here, we had to do some further thinking, right? Because for a judge to be efficient, for it to be good, you needed to give it domain expertise, right? Like how I would judge guitars or the guitar section is very different from how I would judge furniture, for example. So we had to build a system where you could have a generic judge, but then you kind of go, hey, if you're judging this part of the taxonomy, there are special rules through which you're going to judge this part of the taxonomy. And so we created this layered judge approach where if there's no domain expertise, you kind of go, hey, there's a generic judge. And then you can say, hey, but when you come to the electronic section, I have special rules for you. And it gets injected into the prompt of the agent. And then you can even go further. You can say, hey, okay, I know you have special rules for the electronic section, but when you come to the television section, there's even more further refinement that I want to add. So you essentially have these nested judges where it kind of goes, at the top you have like these generic rules that apply to the entire taxonomy, and then you have these cascading nested judges below them, which is frankly very cool. I'm very proud of that work, by the way. And so this is kind of an example of how the judge looks like. So you'll see. That's when I realized one other thing. I said, hey, the judge, if you hear the word judge, it kind of implies a binary yes or no, right? It says, hey, either I allow this change or it doesn't allow. I then realized, hey, we want to go beyond that because I don't want the human to always be correcting. Like if the judge can also do corrections. So in this example, you'll actually see that the decision says approve with fixes, right? What that means is the judges have like different states they can go in. The easiest one is, of course, the judge can look at a change and say, I approve this change. The judge can also look at it and go, nope, this is complete crap, so I'm going to like reject this change. Or, more interestingly, what the judge can do is like, hey, this looks right, but I want to make some changes, right? I want to make some changes before I approve. Think of that like a pull request, right? Like we make a pull request and the judge looks at it and goes, it's cool, I'm going to make some tweaks and then I'm going to merge it in. And then finally, there is a fourth category, which is essentially the judge going, hey, I am not confident with this, and I think a human being should come and look at this right now, right? So the judge will make a plea and it will say, hey, can Ricardo come and take a look at this? And then Ricardo goes in and he fixes it. And so what did we learn? I spoke about the entire system. I spoke about what's happening. Is it all fun and games in production? Not really, right? But again, we were lucky in the sense that we started with the hard problem of like the scale. So we had solved the scale problem in the previous years, but we were still like, we needed this to be resilient in production. And so like I already said at the very start, you can't like overload the prompt. You can't make one agent do many things and then expect it to have great quality everywhere. So we had to simplify, and that's been the guiding principle for us, simplify, simplify, simplify. Because I look at any single box there and I go, can this box be further subdivided into its component parts? If it is, that means you haven't gone deep enough yet with the simplification. We had to build fallbacks as well. So you're talking about all these different agents. Any of those agents can go down at any time. Hopefully not, but they could. And so we still needed fallbacks, and you kind of go, hey, even if this agent doesn't work, you still have graceful degradation. The system doesn't go down. And yeah, so production, it was a fairly standard run in there. And then finally, you got a glimpse of the reasoning stuff when I was showing you the judge. It's not just the judge that has the reasoning. Every step, every agent, and I think the previous speaker was hitting on this as well, you kind of have to keep a log of everything that's happening inside of these agents. Not because like, yes, it's good to reproduce and all of that is cool, but it's also, we want human traceability. I want to be able to go and say, hey, why did this happen? What caused this action to happen? And so we keep those audit trails. It's useful for human review because I can't just send something to a human and say, hey, this was the change. Actually, the human reads, hey, this was the change that was proposed. This is why the LLM proposed the change, and so on and so forth, right? And that actually helps with the human review. And so let's step back just for a second before I head back to Ricardo. The goal of this wasn't to replace my friend here, right? Like, Ricardo is awesome. I really like him. The goal of it wasn't to replace humans. The goal of it was to say, hey, can we build these agents to help scale things and do things faster than we possibly could with the same set of humans, right? And so we went from something that took, and Ricardo's going to give you the actual numbers of how this changed things for him and the operational side of it, but we went from something that was slow. Yes, it was high quality, but it was slow. It was reliable, but it was also like, it was reactive, right? So we went from that system, we kept the same reliability, we kept the same quality, but we just increased the velocity of everything, right? And so you amplify the human, not replace, and then you maintain the same consistency, right? You maintain the same quality. My principle is kind of like, the sum total of a human and an agent should be higher quality than what the human or the agent in isolation can deliver, right? And so that's the baseline expectation we have, and that is what the system is hitting right now. And with that, Ricardo?
Yep. Okay, so I just wanted to show here a quick example of one of the suggestions that we have implemented in our latest version of the taxonomy. So an agent was suggesting this attribute that we were missing in the electronics telephony area. So for smartphones, MagSafe support, for Apple phones, we were missing this for iPhones, and adding what the suggestion was from the LLM agent was MagSafe compatible as a Boolean attribute. What that means is yes or no compatible with this attribute, and then the judge came and analyzed that suggestion from the LLM agent and said, I have 93% confidence on this one. I will show you another example later about what the judgment as well looks for other products, and then it resulted with what is going to be the impact of this change, of this additional attribute. So this is going, for example, to improve filtering, customer filtering that we can do for MagSafe-ready products. And so, yeah, the key insight here is that each agent operates autonomously within its domain, using specialized tools and prompts for focused reasoning. And now what I want to present next very quickly is the human review process. So we have mentioned we have the LLM agents, we have the LLM-as-Judge, but we still want to have humans in the loop. In the earlier stages of this process, the humans in the loop will be much more involved into the whole process. You want to iterate on the LLM agents, you want to iterate on the judge, you want to make sure that these agents are doing the work that you want them to do. And at that point, you may be reviewing up to 100% of all the suggestions that these agents are making. You will be fixing them and then reiterate over the whole process until it gets to the quality that you want it to. But even once you get to that level of quality, you will still want to have some humans in the loop. So continue to review these suggestions. And as taxonomists as well, we may want to, so this system here is suggesting new categories, is suggesting new attributes. Tomorrow, we may want to do some restructuring of our taxonomy and be deleting certain categories or move them to different parts of the tree. So as a taxonomist, I am still going to be the one making that decision. This is what we want to do in the taxonomy, and then we will need to reiterate on the cycle of the agents and the judge. So again, this is not replacing humans or taxonomists. This is just giving them superpowers to do that at scale. And when you have humans in the loop, another thing that we have allowed our judge to do is, as Kay said, it can approve changes, it can approve them with fixes, but it has also the option, we have given the judge the ability to escalate. When it isn't entirely sure about what the decision should be here, or is something very specific to an area, then it's going to escalate for a human to be looking at this particular change and to see whether we accept it or whether we reject it. And those are the things that we are going to be asking. So a few examples here. Let me go back to this one. So is this the right granularity? We are suggesting a new category. Should this be an attribute instead? So we are giving all the logic behind what a category should be, what an attribute should be. the hierarchical consistency as well. So we have this attribute that we have added to shoes, for example, but is this attribute going to apply to every single type of shoe, every subcategory that we have? And that is something that we also want humans to check. Is it consistent, the names that we are using for categories, for attributes, with the other names that we have been using throughout the entire taxonomy? And is it unique? Like, we are adding a new category in this area because we have so many different areas in our taxonomy tree. Are we sure that we are not creating a duplication with another existing concept, or that there is not a significant overlap with any other given category in the tree? So these are all things that we are going to review here. And you have, just an example here. So we have a suggestion. This is an existing category at Shopify, electronics, arcade equipment, and this was a suggestion that the pipeline came up with, bingo machines. We didn't have a specific category for that. And you have the description. So the agents are telling us what the description is going to be for this category. You have the reasoning from the LLM agent and the reasoning from the LLM-Judge, grounding their decision on some products that we have from real Shopify merchants who are selling these specific type of bingo of arcade machines that are bingo machines. And we have the siblings as well. That means the categories that will be at the same level in the taxonomy as this new category, this level 3 category in electronics. And then they're going to be answering these questions. So does it make sense as a leaf category in this area? Is this the best part in the taxonomy tree for this match? If not, what would be a better path or breadcrumb in the taxonomy? Is this consistent with all the other siblings? If not, tell us why. And naming, is this consistent with the namings? And also, most importantly here, is we want to have the details about what is the specific gap. What is this new category given me? What better product understanding do I have now as compared to the parent that we had before? And to understand the exact level. So here, instead of just any other arcade equipment, like, I don't know, like basketball arcade equipment, this is something very specific, bingo equipment, and it's given me that level of detail. So just very quickly on this one, just to give you an example. So when we shipped our taxonomy at Shopify last year, we have been doing this manually with this curation process that was manual based on the suggestions that merchants were making, signals that we were getting from our prediction model. And in the past releases, we were able to create 400 categories, new categories in the taxonomy tree for gaps that we were filling in the actual taxonomy. Now, for our proof of concept for this taxonomy evolution pipeline, we tested it over an area in electronics, communications, telephony, and we accepted, we approved 34 new categories in the telephony area. Now, if you extrapolate that to the whole taxonomy tree, we would be at a place where for all our 25 verticals, instead of having 400 categories, we would have up to more than 10,000 categories filling gaps and getting more options for merchants to, as an example of what categories are used for, we are mapping categories to tax codes. So if you are using a t-shirt or a shop, we are going to provide you with the most appropriate tax code at checkout. So with this, we will have newer categories that we will be able to power that tax system and much faster. So we will be here from years that it would have taken to fill in those gaps, to just run the pipelines for the verticals, review them with the judge, have humans review a percentage of the samples, approve them, put them in the taxonomy, and we could do the whole process in weeks as opposed to years of work. And that's the end of the presentation. Thank you, everyone. We have just 1 minute and a half left.
I was hoping to have more time.
Yeah.
I can stick around if anybody wants to ask me more questions, but we maybe have time for one question.
I will just shout.
Test.
When you built the orchestration layer for your agents, did you lean on an existing open source framework, or did you roll your own, and what drove that decision?
Yeah, we used existing open source frameworks. I've tested them all recently. Like there's many names, right? And most of you know the different names. The one that again, this is not an endorsement or anything. The one that I ended up choosing was Pydantic AI. just because I really liked the type structures there. But again, we could recreate this in any framework. There isn't any secret sauce there. It's a bunch of LLMs. So yeah, like we tested different frameworks. I just ended up liking Pydantic AI, and that's what we deployed. Do we have time for one more? What is it? Yeah. No, so for this one we used bigger models. The inference models itself, my talk last year, for that one we use self-hosted models because the scale of it is just like very, very, like we do tens of millions of predictions daily, multimodal. So for that one, we self-host the models. For this system particularly, like the volume is low and we want the highest possible quality. So for this, we ended up going with I think different agents use different models, but I know we use the best possible models we can there, right? So the scale is small, and so yeah, we go with the bigger models. As long as they let me stay here.
So could you characterize how general you think what you did is? And what I mean is, could you apply it to another taxonomy in a totally different domain, right? If I speculated about this, it seems like you decomposed the problem in a very generalizable way, right? So I don't know if it's something about the prompts or something else that sort of bakes anything in that's e-commerce specific or not.
Yeah, actually, this is something we're actually thinking about. There are ambitions. I'm not going to say there are plans. There are ambitions of like shipping this as an open source thing. So yes, the prompts that each of these agents use has some tie-in back to Shopify and the e-commerce space, but the larger orchestration and the concepts, those I think are generalizable. So, like I think given the state of where it is today, as long as the shape of the taxonomy or the data structure of the taxonomy itself doesn't change so much, I'm pretty sure you could apply this to any other e-commerce taxonomy and it'll do reasonably well. If you want to move beyond the e-commerce space, then I guess just a few changes in the prompts itself, but the framework can run.
We actually have examples where we tested it over using the same pipelines that we were able to adapt to things like return reasons and etc. So yeah. I think that it's highly adaptable.
Yeah, it's very adaptable. And yeah, I know we're out of time. I'll stick around for more questions if anybody has. It just, as it turns out, the Shopify engineering blog just published a blog post about this exact topic earlier this morning. So if anyone's interested, you can go read our blog post as well. So thanks, everyone.
Thanks, everyone.